Okay, let's unpack this. We're talking about code, right?
Hmm.
Specifically, code that does things like grabbing data or saving files.
Yeah, things that don't happen instantly.
Yeah,
Asynchronous operations.
exactly. They sort of run off to the side. And the real challenge is, well, how do you manage a bunch of these at once so your app doesn't, grind to a halt or act weirdly?
Right. Getting that coordination right is key. If you just stopped and waited for everything, it'd be incredibly slow. So understanding these patterns is pretty fundamental.
And one basic way is just doing things one after another.
That's it. Sequential execution. You start one async task, you really wait for it to finish completely,
Mm-hmm.
and only then do you kick off the next one. Super important when, say, the second task needs the result from the first.
Like that recipe idea.
Yeah,
You bake the cake, let it cool, then you frost it. You can't just do it all at once.
precisely. And in code, often you'll see this with await inside an async function. You await task 1, then on the next line, await task 2. Ensures that step-by-step order.
Okay, sequential. Makes total sense for dependencies. But what if the tasks don't care about each other, if they're totally independent?
Good question. Waiting seems like, well, wasted time then, doesn't it?
Yeah.
So that's where parallel execution comes in handy. You basically start multiple tasks around the same time, let them all run concurrently.
Like launching them all together.
Yeah,
And then you just wait for the whole group to finish.
exactly. The main tool here is often something like promise.all. You give it a list of your async tasks. Think of them as promises, like little IOUs for future results.
Yeah.
Promise. AAll then waits until every single one of those promises finishes successfully.
So if even one fails, the whole thing stops. Like it reports an error.
Correct. It's typically an all succeed or it fails situation. If one promise rejects, promise.all usually rejects immediately.
Got it. But the big win is speed, I guess.
Huge speed potential. If tasks are independent, running them in parallel can be way faster than one by one.
Makes sense. So we have sequential for order, parallel for speed with independent tasks. What if you, start several things, but only need the first one that finishes?
Oh, yeah. That's another pattern, sometimes called a race condition, but used deliberately here. You fire off multiple tasks, maybe querying different servers for the same data.
And you just take whichever one answers first.
Exactly that. The tool is promise.race. Give it your list of promises, and it settles, either succeeds or fails as soon as the very first promise in the list settles.
Oh, interesting. So it could be a success or a failure, just whichever happens first.
Precisely. And a really clever use case is for timeouts. You can race your actual task against another promise that's set to fail after, say, 5 seconds.
So if the timeout promise wins the race, you know your main task took too long.
You got it. Lets you
Yeah.
put limits on things. Very handy.
Okay, that's pretty flexible.
Mm.
Now, what if you have, tons of tasks, hundreds maybe, but you're calling some service that can only handle a few at a time?
Right. You can't just launch hundreds in parallel using promise.all. You'd likely crash the service or get errors.
So you need to control the flow somehow, limit
Yep.
how many you run at once.
Exactly. That's rate limiting or concurrency control. It's about managing a pool, maybe thinking of it like having only a certain number of worker slots available.
Okay.
When a task finishes, it frees up a slot, and the next task waiting in line can start. It ensures you don't overwhelm whatever resource you're using.
Like a queue system, basically. Let a few through at a time.
Yeah, that's the core idea. It often involves managing queues and tracking active tasks. But honestly, implementing this robustly, handling errors, retries, stuff like that, it can get complex.
I bet.
Which is why often for serious concurrency management, people reach for dedicated libraries that have already solved these tricky problems.
Makes sense. Okay, so wrapping up, we've got sequential with await, parallel with promise.all, grabbing the first result with promise.race, and then managing many tasks with concurrency control.
Yep. And knowing which pattern fits your specific situation, do you need order? Are tasks independent? Do you need the fastest? Are there limits? That's crucial for writing efficient, solid async code.
So think about your own code. When you've had to wait for something, fetching, saving, whatever,
Mm-hmm.
could one of these patterns have helped? Maybe made it faster or just more reliable?
And consider the flip side, What breaks if you forget to await when you need order? Or if you try to run 1,000 tasks in parallel without any limits? Which of these patterns feels like it might solve a puzzle you're working on or one you see coming up?